Hello students, now today we are going to start the topic that is a AC fundamental circuits problem related to the second number topic for 11 standard AC fundamental and the circuit. Okay, the first problem, that is a peak to peak voltage of a sine wave is a 350 volt. Calculate the average value and the RMS value of the voltage. As you know that the wave consisting of the positive value and the negative value, the positive value for it is indicated with a plus Vm, and for the negative value it is indicated with a minus Vm, and if we are able to combine both these two, then you are getting the value that is Vpp. Okay, this Vpp it is given as a 350 volt. Then what we have to do, we have to find out the peak voltage, that is a Vm. Since Vm is equal to, as we are going to make the value half, it is 350 divided by 2, you are getting the answer as a 175 volt. After that, as you know that the average voltage is given by the formula, that is a standard formula, that is 0.637 multiplied by, again the value for the Vm has been assigned to you. This 0.637 multiplied by Vm, that is 175, it will give you the value 111.48 volt. So this is the average value. Okay, it is average voltage for this one. Then the second number, it is given by the RMS voltage. RMS voltage, again the standard value has been assigned to you, that is 0.707 multiplied by Vm. Only just what you have to put out, you have to put only the value for the Vm. Okay students, so this value for the Vm we have calculated as a 175. So 0.707 multiplied by Vm, it is 175. Then at the end you are getting the answer, that is 123.7 volt. So in a box you make down so that it should be get highlighted. RMS voltage is equal to 123.7 volt. In this box, every answer, whatever the answer you are getting, you have to mark it in a box so that it must be highlighted. Here also Vm is equal to this one. Okay, the next number, you have calculate the time delay for the phase angle of a 60 degree at a frequency of 1 kilohertz, and a second number, that is a 3 megahertz. Okay students, you have the formula. Which formula you have to remember? You have to remember the formula, that is T is equal to theta divided by 360 degree multiplied by 1 upon F. So this is the formula. From this one particular formula you are able to identify the, at a frequency of 1 kilohertz and a 3 megahertz, the time delay for the phase angle of a 60 degree. This theta has been assigned to, that is a 60 degree. Okay, and what you have given the frequency for the 1 kilohertz, you have to calculate the phase angle, that is a time delay, and the 3 megahertz you have to calculate the time delay. So very first, for you write down, for 1 kilohertz, you will get the value, that is T is equal to theta, it is given, that is 60 degree, then 360 multiplied by the frequency is given 1 into 10 raised to power 3. Okay, so here 60 means 1 by 6 multiplied by 1 upon 1000, able to cross multiply, then it will be 1 by 6000 is equal to 6000. You are getting the value, then it remains this one, it is 1 by 6 into 10 raised to power minus 3. So you will be getting 0.166 millisecond. Okay, this 3 if we take upward, then it is 10 raised to power minus 3, that's why it is a millisecond. It is the first value for 1 kilohertz. Then for the second number, for 3 megahertz, you are getting again 60 divided by 360 multiplied by 1 divided by 3 into 10 raised to power 6. Okay, so again 1 upon 6 multiply by 1 upon 6 multiply by 1 divided by 3 into 10 raised to power 6. At the end, if we calculate all the values, then 18 into 10 raised to power 6, it will go upside. The value will be 0.055 microsecond. Okay, this much is the value you should be obtained for the 3 megahertz. Okay, then comes a third number problem. This is the problem. The sound wave and the electromagnetic wave both the same frequency of a 2 kilohertz. Calculate the wavelength of each cases. Okay, so you have the formula, that is lambda. Lambda is equal to velocity divided by frequency. Velocity divided by frequency. You know the velocity. That is 3 multiplied by 10 raised to power 8 meter per second divided by 2 into 10 raised to power 3 hertz. So you will be getting, that is 1.5 multiplied by 10 raised to power 5 meter. Okay students, it is nothing but 150 kilometer. Okay, in case of that particular electromagnetic wave. Then second number, in case of sound wave. In this sound wave, again lambda is equal to 330 millisecond divided by 2 into 10 raised to power 3 hertz. What you will be getting? It will give you this 165 divided by 10 raised to power 3. You will be getting 0.165 meter. Okay, so in the sound wave you are getting the value, that is 0.165 meter. It is a next problem. Then comes a fourth number problem. The sine wave of the voltage varies from 0 to the maximum of 150 volt. How much is the voltage at an instant of 30 degree, 60 degree, 90 degree and 210 degree? It is very much simple problem. Just one formula in previous video I told you, that is V is equal to Vm sine theta. Okay, what is given to you? The maximum voltage, that is Vm. Vm has been assigned to you, that is 150 volt. It is 150 volt. Then the theta has been assigned to you, that is 30 degree, 60 degree, 90 degree and 210 degree. Okay, only just you have to find out the V. So for the first, at 30 degree, the value V is equal to 150 sine the first number theta, that is 30 degree. At 30 degree we will be going to find out. So 150, the value for the sine t, that is sine 30, is nothing but it is 0.5. so you will be getting 75 volt. Second number, at 60 degree, again V is equal to 150 sine of 60. 150, yeah, sine 60 is nothing but it is 0.866. then at the end you will be getting 129.9 volt. Then for the third number, at 90 degree, the V is equal to 150 multiplied by sine 90. It is 150 multiplied by sine 90, it is 1, and that's why you are getting 150 volt. Then the fourth number, for 210, at 210 degree, V is equal to 150 with a sine 210. It is 150 multiplied by sine 210. You are getting, that is minus 0.5 is equal to, it is 75 volt. So in this way the 4 problems has to be get solved by you. Okay, the next number problem, it is given, that is calculate the period of the frequency of 5 megahertz, first number. Second, calculate the frequency for the period of 0.8 microsecond. Then third number, the 50 hertz power line voltage of 230 volt is applied across the resistance, okay, of resistance of 25 ohms. How much is the RMS current? Okay, this is the RMS current. And then uh, how much is the RMS current in the circuit? How is the DC voltage would be necessary for the same heating effect in the resistance? Okay students, this is the problem assigned to you. You have, what is the given value? The frequency value, frequency it is given by F is equal to 1 upon T. Okay, this T is nothing but it is a period. So since T is equal to 1 upon F, we will be getting T is equal to 1 upon F. You have the frequency, it is 5 megahertz. Okay, so T is equal to 1 divided by 5 into 10 to the power 6 is equal to, it is 0.2 microsecond. The T, first number value, the T is equal to 0.2 microsecond. Then for the second number, the frequency F is equal to again 1 divided by, it is 0.8 multiplied by 10 raised to power minus 6 is equal to, after solving you will be getting 1.25 megahertz. Okay, then the third number, that is RMS current. RMS current is equal to, that is VRMS divided by R. Here one thing you have to keep in your mind, that V is equal to I into R, that is nothing but I is equal to V upon R. This formula has been arised from this value. Okay, so this V is equal to I by R, I is equal to V upon R. Since we have to write down the RMS value, what is the RMS value for the voltage? It is given, it is a standard value given, it is 230 volt, so we will write down 230 volt here. And what is the value for the resistance applied across the resistance? It is 25 ohms. So just write down 25, and after calculation you will be getting, that is 9.2 ampere. So this much is the RMS current flowing from the circuit. Okay, then the next number problem, in the following circuit calculate the impedance, current and the voltage drop across each component. Okay students, so the diagram has been assigned to you. You have given the voltage value, that is 150 volt, the R value, the resistance value, it is 50 ohms, XC, okay, that is 100 ohms, XL, it is 25 ohms. Now first, what is the main thing? You have to write down V is equal to 150 volt. Okay, it is 150 volt. Then R is equal to 50 ohms. Then XC is equal to 100 ohms. Then XL is equal to 25 ohms. Okay students, the first number, that is Z, means the impedance. We have to calculate. We have the formula, that is R square plus X square with a whole root. Since the value for X it is assigned by XL minus XC. This XL minus XC, it is 100 minus 25. Okay, it is nothing but it is 75. So directly you may write down here 75 square, or just you write down X. What is the value for R? It is 50 square plus XL minus XC. We have found out the value, that is 75. Here we will write down, that is 50 square plus 75 square with a whole root. After calculation you will be getting the answer, that is 2500 plus 75 square, it is 5625, 5625 whole square, it is equal to, with a root, and then 90.14 ohms. Okay students, then the second number problem, it is of a current. You have to find out the current, that is means it is I is equal to V upon Z. Okay, so what is the value for the V? It is assigned, it is 150, and the value for the Z we have just found out, it is 90.14. so 150 divided by 90.14, you what you will be getting, it is 1.66 1.66 ampere. Okay, then C number, this C number, it is of the voltage drop across each component. Okay, here C number, voltage drop across each component. So each component is nothing but XL, XC and XL, XC and R. So first number, that is VR, is equal to, the value for the VR, it is I into R. What is the value for I? It is 1.66 multiplied by the value for the R, it is assigned, it is 50. So multiply by 50, you will be getting the 83 volt. Then the second number, VC is equal to I into XC, 1.66 multiplied by 1.66 multiplied by XC. XC, it is 100. Okay, 100, then you will be getting 166 volt. Then VL, VL is equal to I into XL, it is 1.66 multiplied by the value for the XL, it is 25. So you will be getting 41.5 volt. Okay students, so these are few problems related to the topic which you have to keep in your mind in such a way that whenever in the examination it is going to be asked, you are able to solve the problem. Okay, there are again 2 or 3 problems which we will solve. The next problem, that is 7th number problem. Calculate the resonant frequency for 0.25 microhenry, okay, inductance and 2 picofarad capacitance. Here in this problem, simple, the formula has been assigned to you, that is Fr is equal to 1 upon 2 pi under root of Lc. It is 1 upon 2 pi under root of Lc. So what is given to you? 0.25 microhenry, that is the value for the inductance, and 2 p of capacitance value has been assigned to you. So only the value you have to insert inside the formula. 2 multiplied by the pi value, it is assigned 3.14, then under root of, it is first number 0.25 multiplied by 10 raised to power minus 6 multiplied by 2 multiplied by 10 raised to power minus 12. Okay students, so 1 divided by, here 826 under root of 0.25 multiplied by 10 raised to power minus 6 multiplied by 2 multiplied by 10 raised to power minus 12. Okay, after calculation you are getting the answer, that is 1 means here you will be getting 225.19 megahertz. Okay, it is the resonant frequency. Okay, the next number problem, 8 number problem. The value for, what is the value? What is the value of C resonant with 300 microhenry inductance at 1500 kilohertz? Okay, so again the same thing you have to keep, that is Fr is equal to 1 upon 2 pi under root of L into C. Okay, what is the value for C? This C we have to find out. If we take outside the value, then this C is equal to, you are be getting, that is 1 upon 4 pi square L into Fr square. Now it is very much simple. So the value for the L is given to you, that is 300 microhenry. The value for the Fr, it is 1500 kilohertz. Okay, we will get directly the value for the C. So just you write down 1 divided by 4 multiplied by 3.14 square multiplied by L value. The value for the L, it is 300 microhenry. So just you write down 300 multiplied by 10 raised to power minus 6 multiplied by Fr frequency, that is 1500 kilohertz. So just it is 1500 multiplied by 10 raised to power 3 whole square. Okay, so after calculation you will be getting, that is a 37.56 multiplied by 10 raised to power minus 12 farad, since 37.56 pf you are getting as a C. Okay, so these are the problems. Then next one problem remains. Ninth number problem we will solve. An LC series circuit, an LC circuit resonant at 1500 hertz kilohertz has a bandwidth of 10 kilohertz. Calculate Q. Okay, here also the Q value has been assigned to, that is Fr divided by del of F. The Fr, it is nothing but resonant frequency, and del of F, it is nothing but it is a bandwidth. So directly Q is equal to Fr divided by del of F is equal to, you are getting Fr frequency, it is 1500 multiplied by 10 raised to power 3, and the del F, it is 10 kilohertz. 10 multiplied by 10 raised to power 3, so divide it one, you will be getting 150, since Q is equal to 150 is the value assigned to you. Okay, so students, these are the small problems which is very much important from your 11th standard examination point of view. Okay, yes, thank you.